Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1, and today's chapter is applications of partial derivative. That means these are the application based on previous chapter that was partial derivative. So let's start with the today's topic, gradient of a scalar field. What is gradient and what is scalar field? Let's have a look on the topic. First, start with the gradient of scalar field. The gradient of a scalar function f of x comma y comma z is equal to 0. This this function is called scalar field. That means scalar function. So gradient of a scalar function, this is vector function. That means if we find the gradient of this function, it will be our vector function and it is denoted by grade f. We denote this as a grade f or del f. We can say this symbol as del or nebula. Okay, del or nebula, and is defined as this: grade f is equal to del f is equal to del by del x I plus del by del y j plus del by del z k of f. Now if we apply f, or if we apply this bracket on f, so we have del f by del x into I caret plus del f by del y into j caret plus del f by del z into k caret, and we know that this function, these derivatives are function of xyz, and because of I j k, this is vector, so we can say that this is vector function. So gradient of a scalar field gives us a vector field, that means vector function. And here this del is equal to del by del x into I caret plus del by del y into j caret plus del by del z into k caret is known as differential operator. So this del is known as a differential operator here. Okay, now how we find this gradient of any scalar function or scalar field? Let's have a look on the example. Okay, first example: if phi is equal to 3x square y minus y cube into z square, then find grade phi at point 1 minus 2 minus 1. That means we have to find grade phi at point this. So first we will find grade phi and then we will put the value of x, y and z. So start with the solution. First write down the given function and point P is equal to this, which is given in the question. Now what is the definition of grade phi? We already seen. So grade phi is equal to, we can say del phi also, and is equal to del phi by del x into I cap plus del phi by del y into j cap plus del phi by del z into k cap. That means we will differentiate this given function partially with respect to x, partially with respect to y, and partially with respect to z. For that we will use rule of partial derivative. That's why this is the application, because here we are using rule of partial derivatives. Okay, now we will find the derivative of this phi with respect to x. So differentiation of this first term is 3 constant, y constant, and differentiation of x square is 2x. So we have 6xy, and differentiation of y cube z square becomes 0. So we have 6xy only. Now same way with respect to y, this term contains y, so 3x square constant, and differentiation of y is 1, minus differentiation of y cube is 3y square and z square constant. So we have this term into j caret as it is, plus differentiation of phi with respect to z. So in this term there is no z, so it is 0, and here z square is occur, so the differentiation of z square is 2z and y cube constant. So we have minus 2y square, minus 2 y cube z and k caret as it is. Now just by simplifying, or we can take this minus outside, or we can put as it is. And now this is our grade 5, but now we want to find at point this, that means we will put p point 1 minus 2 minus 1. So we put x is 1, y is minus 2, and z is minus 1 in this del phi. So we have this becomes 6 into 1 into minus 2, this is minus 12. 3 into 1 square, that means 3, and 3 into 2 square, that means 4, and minus 1 square is 1, so 4 is 12, and 3 minus 12 is minus 9. And if you put y cube, this minus 2 cube is minus 8, and this is minus 1. So minus 2 into minus 8 into minus 1 is minus 16. So we have, this is our answer, and we can write this as in point form, as you know, minus 12 minus 9 minus 16. Okay, now let's start with the one more example. Example is, if r vector r is written as r this or r bar also. Okay, so you can write this or this. So vector r is xi plus yj plus zk. Whenever I am telling that I'm using ijk, that means I cap, j cap, and k cap, because we know that what is ijk. Ijk are unit vector in the direction of x-axis, y-axis, and z-axis respectively. Okay, so r vector is equal to xi plus yj plus zk, and r is equal to mod r vector. Here this is r, not r vector. So this is r is equal to r vector. Modulus of r vector is equal to under root x square plus y square plus z square. Then show that number 1, del r is equal to r cap, del 1 by r is equal to minus r cap upon r square, del r raised to n is equal to n into r raised to n minus 1 into r vector, del r vector mod r vector whole square is equal to 2 r vector, and del log r is equal to 1 by r into r cap. Now what is r cap and what is r vector? For that we will understand here. We have, if we have vector r is equal to xi plus yj plus zk, then if we take modulus of this vector, then modulus of any vector is given by under root of x square plus y square plus z square. This is the formula of modulus, magnitude or modulus of any vector. And magnitude of any vector is denoted by simple r. That means this vector symbol is removed. Now what is r cap? That means r cap is equal to vector divided by its magnitude, vector divided by its magnitude, and this is known as unit vector. This is known as unit vector. So this you have to understand. These are the basic for today's lecture. Okay, now we have to prove all these 5. Okay, so let's start with the first number 1. Let's start with r. Vector r is given, and now we have the basic concept, magnitude of any vector, and how to find unit vector. Unit vector, that means vector divided by its magnitude. Now first we will find mod r. Mod r, that means magnitude of r, which is written as small r only. Okay, and which is given by under root of x square plus y square plus z square. Now if we take square on both sides, so this become magnitude of vector r whole square is equal to r square is equal to this, because if we take square on both sides, so this root is removed. Okay, so we have this term. Now differentiating partially with respect to x, we differentiate this term, entire term with respect to x, and this already we have seen in chapter partial derivative. So differentiation of r square is 2r, and differentiation of r is del r by del x because r is a function of x, y, z, and differentiation of right hand side is 2x only because we are differentiating partially with respect to x. So y and z is constant and differentiation of constant is 0. By cancel out 2, we have del r by del x is equal to x by r. Similarly, we have del r by del y is equal to y by r and del r by del z is equal to z by r. Now we start with the number 1, del r. Del r, this del means gradient of r. Gradient of r is a function, okay, which is under root of x square, under root of this x square plus y square plus z square. So gradient of r, and now we have to prove r cap, that means this we have to prove vector divided by its magnitude. So let's start with number 1. We have number 1, del r is equal to r cap, that we want to prove. So we'll start with the left hand side. What is the meaning of del r? Del r, that means grade r. Grade r is equal to del by del x of r into I vector, del by del y of r into j vector, del by del z of r into k vector. As we have seen, if we want del f, that means del by del x I cap plus del by del y, j cap plus del by del z, k cap of f. So we multiplied this f into bracket. So we have del f by del x, I cap plus del f by del y, j cap plus del f by del z, k cap. And same concept we used here. R multiplied in this bracket. So r. Now we have all these three derivatives we already just find. So we have x by r, y by r, z by r. We can take r common, so 1 by r common, and we have xi plus yj plus zk, and which is our vector r. Vector r, and we know that what is the formula for small r. As I told you that r is magnitude of vector r. So we have r upon magnitude of this r, and which is our r cap, that means unit vector, and hence it is proved. Simple, so simple. We are just using derivative only and this formula of grade. Okay, other than this there is no any concept in gradient of scalar field. Number 2, we have gradient of 1 by r is equal to minus r cap upon r square, that we want to prove. So first we will start with the gradient of 1 by r, that means del by del x of 1 by r. This is our function f. So f here, and f here. Now differentiating with respect to x, differentiation of 1 by r is, we know that what is the formula of differentiation of 1 by x? Minus 1 by x square. Or as I told you in previous lectures, if you remember that 1 by something, that is minus 1 by something square into differentiation of something. So minus 1 by r square, and differentiation of r is del r by del x. Same as minus 1 by r square, and differentiation of r with respect to y is del r by del y. Same for z, del r by del z. Now we have all these three values, so we can put x by r, y by r, and z by r. So we have this, and by simplifying this minus x, we can take this r square into r common, and minus also we can take common. So in bracket xi plus yj plus zk, and this is our r vector. So we can write r vector. Now we can take this r from this r cube. So we have r vector r upon r, and this r is, we know that magnitude of vector r, and vector upon its magnitude gives us r cap, that means unit vector, and r square as it is. So we have final answer minus r square as it is, and this vector upon magnitude give r cap, that means unit vector. Okay, so simple derivative. Just you have to refer all previous lectures of partial derivative. by using pen and paper. Then only then you can understand this chapter better, because in this chapter you have to remember the concept of this chapter, and basic concepts are depend on the previous chapter, that means derivatives, okay, partial derivatives. Now number 3, we have del r raised to n, that means gradient of r raised to n is equal to this, we have to prove. So let's start with the gradient of r raised to n, that means del by del x of r raised to n, del by del y of r raised to n, del by del z of r raised to n. Now derivative of r raised to n is n into r raised to n minus 1, and r is a function, so del r by del x. Same way with respect to y, with respect to z. Now we know the formula of these three, as we have already find x by r, y by r, and z by r. We just write down. Now we can combine this r and r, so r raised to n minus 2, r raised to n minus 2, r raised to n minus 2, and we can take common. So n common and r raised to n minus 2 common. So we have x into I caret, y into j caret, z into k caret, which is our vector r and which is our solution. So hence it is proved. Now number 4. So easy, just you have to use basic rule. Now find gradient of mod r vector whole square. So let's start with the proof. Now we know the formula for this mod r vector whole square. As I told, we have vector r is xi plus yj plus zk. So magnitude of this is under root of x square plus y square plus z square, and if taking square on both sides, we will get x square plus y square plus z square. So I am using this one here. Now del of this, the gradient of this one means del by del x of this into I plus del by del y of this into j plus del by del z of this function. Okay, so differentiating with respect to x, only this term will be differentiated, and this will give us 0. So 2x here with respect to y, so 2y, here with respect to z, so 2z, and if we take common 2, so we have xi plus yj plus zk, and which is our vector r, so we have 2r vector. Okay, same way we have number 5, which is gradient of log r, and gradient of log r is del by del x of log r, del by del y of log r, del by del z of log r, and ijk is by default because it is in formula of gradient. Now what is the formula of log r? 1 by r, and differentiation of r with respect to x is del r by del x. Same way with respect to y, del r by del y. Same way with respect to z, del r by del z, and differentiation of log r is 1 by r by default. Now what is the formula of these three? We know that x by r, y by r, and z by r. So we can take r square common, or we can take 1 by r common only. So the denominator r, and this is our vector r. So vector r, and we know that this r is what? Magnitude of vector r. So vector r upon magnitude gives us r cap. So r cap into 1 by r, this is our final answer. And these are the some basic example based on gradient. Only 3 example. Just practice this example so you can understand two things: how to find gradient as well as how to differentiate. That means revision of partial derivative. Okay, so thank you for watching this video. We will see you soon with the next lecture. Thank you.